This is a Ventra Pro video on setting up a ceiling inlet. So that's often when you have a finished ceiling in a especially with a hog environment, they will have ceiling inlets to provide air coming in through the attic, and especially in cooler weather, that'll be able to warm it slightly before it comes in and is able to mix up at the top of the building where it'll mix nicely with the hot air that's tending to rise. And it'll make the cool air from outside modified, and if we can have it come in with a decent static pressure, it'll actually mix nicely, and that's what we really want to achieve. So it's important to set these correctly. We're going to go into channel 3 where we've set up our open for the ceiling inlet. The first option is operate as, so we can set it up to operate it as temp natural, which will include powered ventilation in this case, because you wouldn't be doing this if you didn't have fans. If we click through, we can do natural and tunnel. Typically you'd want to have ceiling inlets closed, so the preferred option is just temp natural. Temp static tunnel, we can also do temp natural or just plain temp tunnel with this inlet. The obvious choices are either to do with static pressure on a natural, which again includes our cooling stages, or what we call powered ventilation, not tunnel, or our other option would be to just do temp natural only, and we'll just do that one and show the way it can be set up. If you have it set up, we'll do that first, and we'll show how you can set that up with typical proportional settings for this inlet. So we're going to go down, and now since we've gone temp natural, it's going to do proportional settings. In this case, when we start off with a 0 and 0, it's going to try to, when it's between no fans and the first full fan being on, it will try to find the spots between this 0 and what the next spot is set at half a fan. And this setting will take place once it's up past like a power setting of 32 with the fan itself, and then it'll go to this 1-inch opening that we've set. And so by having the opening gradually increase, we're going to be able to maintain a relatively consistent static pressure differential from inside to outside. I'm going to one fan, went to 1.5 inches. These are 9-inch, series of 9-inch opening ceiling inlets. 1.5 at 2 inches, 2 fans. So that those first two are variable speed single phase fans that could be not running, that could be a full fan, or they could be part of a fan because they might be in the ramp portion where they're running less than full speed. So that's what that covers. Once it gets to 2 full fans, those variable fans are full on. We're at 2.5 inches, and from there it increments by full fans, because in this setup the next fans are going to be just on-off relay fans. So 3 fans at 5 inches and 4 fans at 9 inches. So likely that 4th fan is a bigger fan than the previous ones. After the 4 fans, in this particular instance, we're talking about a relatively small, like a swine application. All the other slots in here need to have 0 and 0, because they do come populated with values, and it can definitely mess things up if we don't get those set right. An option here, instead of going 0 and 0, we could have started in our first slot with half a fan and the 1 inch. And what we would accomplish there is basically it wouldn't try to get something less than that 1 inch at various places leading up to half a fan. So once it's running at a slower speed, lower than 32, let's say, if our minimum is set at 30, it might see that as less than half a fan. Well, if we set it up that way, we wouldn't have that issue. And there is a reason to do that. So those are the settings that we've got for various amounts of the fans come on by temperature, and then when they the number of fans counted up, all set as proportional, will be what's used here to decide what opening size that sealing inlet should be at, so that we can get the static pressure we want. Now, you can find out by using a static pressure sensor or some trial and error with using airspeed coming out of the actual sealing inlets to calculate what the actual static pressure would be based on opening size and airspeed. You can find out what we're actually have for a static pressure differential. So those things all can help us to maintain a reasonable static pressure, not too high, not too low, and especially not too low in the wintertime when we're trying to bring in less air, but enough for the animals, and then might still have an issue with it affecting, if you have the inlets open too far, that the static pressure goes down low, and that cold air from that sealing inlet just dumps straight down on the animals below. So there's each of these steps needs to be well thought out. So the next one is natural interlock to all fans. That's the way I approach this. I just left it all fans. It's a simpler approach. You can actually have each of those steps that we did above, the number sign 01, number 2, number sign 02, and so on, each have an interlock to a particular fan. But I'm just trying to keep it simple here to avoid complicating matters. Sometimes we forget what we have in all these settings. You can plus through these once you set it to individual fans to get to other interlocks. But we're going to just skip that to keep that easier. Cooling opening sizes are proportional in this case. The choice with proportional, you can choose stepping. Now, the reason why you choose stepping is probably in this case we want stepping. So we'll explain that in just a minute. And here's the reason. We have a 9-inch full opening size, and our travels to go from full close to full open is 52 seconds. From full open to full close is also 52 seconds. And the controller will not make moves correctly or usually at all if it takes less than 3 seconds to make the move. So if you're making a change between less than, let's say, half an inch, in this case would be a problem, because 52 seconds on 9 inches means that you've got approximately 5.8 seconds per inch that it will take. So that's fine if you move an inch. If you move half an inch, that's less than 3 seconds. So basically we would assume that a 0.6 inches would, in this case with these numbers, would be the minimum that you'd want to move. So to accommodate that, we can do that first proportional setting, that number 01 at the half a fan and the 1 inch, and then it's just going to be able to start right at that point. It won't open at all till that fan gets to being a full half a fan or 32 power or higher power level. And then the other setting that we had that we talked about of doing stepping, will just move it when it gets to the next step in our step here. So if our first step is this half a fan 1 inch, and the next step is 1 fan 1.5 inches, it won't change that position until it gets to the full 1 inch if it's stepping. If it's set instead to proportional here, it's going to try to make those changes as we go. So in that case, especially when we have an actuator like in this case that is moving pretty quickly and has a short full run time, we'd want to definitely consider doing that. Taking out that 0 and 0, and then also doing stepping. The other thing we could do in this case, because our problem is this short duration, is double pulley the actuator that runs that series of sealing inlets. And then our runtime would go from 52 seconds to 104 seconds. So that also would help us a great deal. So those are just some things to keep in mind that could be an issue when setting up a sealing inlet. So we've got our pre-open timers, the next thing. Pre-open timer is only affected if we're doing a timed actuation of this inlet. It won't do a pre-open when we're working by temperature like we're doing right now. So if we chose to operate the inlet based on a timed fan, we could actually use this, but typically when it's set to 0, we're not going to be able to use that. That disables any of the functions. Also, tunnel entry, when this thing transitions to tunnel. Now when we transition on a tunnel inlet, this would be probably 6 inches or some value, and this one would be 0. In this case, it'd be 0 when we enter tunnel, but when we exit, we want to already have our inlet open so we don't overdo our static pressure in the building when we're transitioning. Perform resync is a time of day that once a day it would resync. It would go to the closest, either full open or full close, and we set that with a 24-hour clock. So when it's set to 000, it's disabled for right now. But if we set it for a particular time, it would make sure that it's been calibrated once a day. The next thing that is on here is close to a certain number of inches when curtain is greater than a certain amount. Well, this only is affected if you're doing a power to natural type barn where you have cooling fans and then you transition to sidewall curtains as your higher level of ventilation or cooling. And in that case, you can choose to open up to a certain amount the ceiling inlets to allow a little bit of convection. It doesn't work fabulously, but it's an option that you have if you want to try to get a little more air exhausting out through these inlets. You could do that. And then we come around to what we're going to operate our inlet at again. So that gives us a pretty good range of options. The other option that we could look at just quickly is if you chose to just do this one as temp or static natural only. So this is only going to come up if we have a static pressure sensor installed in the system. But now once we go to here, we don't have to worry about the proportional steps and them meeting the proper criteria for static pressure. This is going to run off of static pressure. The other settings are much the same as before. It's just that we don't have to worry about any of those things having to do with the particular steps that we want it to go to based on numbers of fans, because it'll adjust by static. So if we cancel out and arrow around until we get to the static pressure settings for natural, which in this case we can change this setting and wherever we want it. So let's say we do want 0.09 as our target, and then this is where you provide a window so that it isn't trying to hunt for that exact 0.09 value. And so in this case, 0.07 to 0.11 is a good option for what we're trying to accomplish. We'll leave that. And whatever we set for the natural static pressure settings will also be the same offset. So from 0.09, we have 0.02 below to 0.02 above. Whatever we have set for the natural will also be the ones that will be used for the same offset on our whatever we set for tunnel mode if we're using a static tunnel mode.